Good day everyone, and welcome to another video of Mr. Today we are going to be looking at the topic matrices. That is our topic for today, and let us dive right into the video. Topic that many people find very difficult, and we're going to be trying to simplify matrix in the best way that we can. Now, but before we can actually discuss about what matrices are all about, let's look at what are rows and columns. Now, if you look at the diagram here, you can see illustration of a group of people holding hands together. Each of those single line of people forms a row, and you can see the bars at the last picture, the bars, each of those bars standing singly, each of them is called a column. So you can see that the row is more or less the horizontal, while the column vertical. So let us look at our slide and let us look at what are rows and columns. Now, the row is a part of a matrix where elements are arranged in a horizontal manner, while the column is the part of a matrix where elements are arranged in the vertical manner, as was shown in the previous slide. As we can see that there were the horizontal bars, the horizontal lines, which were the rows, and the vertical bars, which were the columns. Now, the order of any matrix is given in the form m by n, usually written as m times n, where m is the number of rows and n is columns, as we will shortly see. Now, let us just now tell each other what a matrix is. What is a matrix? Now, the matrix is a rectangular array of numbers, figures or expression organized in rows and columns. So it is basically arrangement in rows and columns, usually of figures, expressions, or numbers. Now, the size of a matrix, like we said, is determined by the number of rows or columns that are present. So the number of rows or columns will determine the size of the matrix. For instance, if a matrix is given as m by n, it means it has m rows and n columns. For example, we can see the matrix A, which is shown in the picture here, has two rows. 1, 2, 3 is the first row, 4, 5, 6 is the second row. It has two rows and three columns. 1, 4, 2, 5, 3, 6 are the three columns. So it is a 2 by 3 matrix, 2 rows, 3 columns. While the matrix B has matrix. So let us look at matrix notation. What is matrix notation? Matrix notation is the way in which elements of a matrix can be represented in a single general element, usually A. Now, this notation will show the location with respect to the row and the column, where the location in the row is usually represented by I, and the location in the column is usually represented by J. From a matrix given below, you can see that each of the rows and columns are numbered. We have row 1, 2, 3 in the green, written in the green colors, and we have 1, 2, 3 up to n written in the red colors. So if I want to denote a matrix, which is the first element, we have A11. It means it is in the first row and the first column. You can see A21. It is in the second row, but it is also in the first column. So that is matrix notation. This can enable us to locate any matrix. So all I need to give is the notation of a matrix, and you can locate that element easily. So that is it. So let's look at equal matrix. When is a matrix said to be equal? Now, two matrices are said to be equal if they have the same order and the corresponding elements are equal. Once two matrices have the same order or size and their corresponding elements are equal, they are said to be equal matrices. So in a simpler form, if you have matrix A and matrix B, A subscript ij must be equal to B subscript ij, meaning that all the elements of A must be equivalent to the corresponding elements of B. So if you have A12 is 5, meaning B12 has to also be 5. If A11 is 7, B11 must also be what? 7. Now, as we can see in the table below, you can see that A and B, whether it's A11, A12, you're considering A21 and A22, they are similar to what is in B. But as you can see, look at C, there's a slight variation. Because of there's a slight variation at all in between 19 and minus 2, A is not equals to C and B is not equals to C, and also M is not even of the same size, so you cannot equal. Let us look at how to now add and subtract matrix. It is enough to actually understand what the matrix is. It is not enough to understand what the matrix is. We also have to try and see how we can add them, subtract them, basically how to perform basic operations on them. Now, before two matrices can be added or subtracted, there is a certain condition that must be fulfilled. And that condition is they must have the same order or size. If two matrices are not of the same order, then you cannot add them. For example, A plus B in the diagram given below is possible because A and B are of the same order. They are both 2 by 2 matrices. Unlike the last matrix here, which is a 3 by 2 matrix, cannot add a 2 by 3 matrix. So this is a condition that we must satisfy, that the size of the two matrices must be the same. And what that has been satisfied, all you have to do is to add the corresponding elements. As you can see, A1 will add B1, A2 will add B2, A3 will add B3, and A4 will add B4. This will actually complete the matrix. Let us look at multiplication of matrices. When we talk about multiplication of matrices, we have two types. We have the scalar multiplication and the multiplication of two matrices. Now, what is the scalar multiplication? This is the multiplication of a matrix by a single number. Every element in the matrix is multiplied by that single number, usually called a scalar. So usually we have this single number, usually a general number like constant. It could be 1, 2, 3, 4, 5, any number, 10, 50, 1 over 5. As far as it is a number, and this number is called a scalar. So this scalar will multiply the matrix by multiplying each of the individual elements. So mathematically it is written that if all the elements are A subscript ij, then the constant is k, then the scalar multiplication of that will give you k aij, meaning k multiplying every element of A, as we can see. And also, if we can also use it to multiply, we can also factor it out. For instance, if you look at this diagram here, you can see that A is 3, 7, 9, 10, and 2A is basically using 2 to multiply each of the elements given there. And you can see that we can form a new matrix, which is 6, 14, 18, and 20. Now, this is just scalar multiplication in its simplest form. Also, although it doesn't go beyond this, scalar multiplication cannot get harder than this. They can try and mix it up and stuff. Like when we actually have the calculation class, where we're going to actually solve several questions on this, you would understand better. But you can see that it doesn't go beyond this. It cannot go beyond this. Also, the same way we brought into this, we can also factorize out 2, which is, we can call it scalar division, although it's not really called scalar division. It's just called factoring out a scalar from a. So let's look at the second type of multiplication of matrices, which is the multiplication of two matrices. Now, two matrices A and B can only be multiplied if they satisfy a certain condition. Now, what is the condition? That the number of columns in the first matrix A must be equal to the number of rows in the second matrix B. Only and only if this condition is satisfied can two matrices be multiplied. Now, after this condition has been satisfied, are you done? No. You now have to actually multiply it. Now, what do we do when we want to multiply? The first thing, you take the first row of the first matrix. Let's look at the example we have here. We have the matrix, the 2 by 3 matrix here, and we have the 3 by 2 matrix here. Now, it is possible because this multiplication is possible because the first, the matrix A, the number of columns in A is 1, 2, 3, and is equal to the number of rows in B, which is 1, 2, 3. So you see that this is actually possible. And then we can, as you can see, you have this is the first row, this is This is the first column, second column, third column, and this is first row, second row, third row. So you can see that it satisfies that condition. And because it satisfies that condition, we can actually proceed with the multiplication. So what do? We take this first row and multiply this first column, and that forms our first input. So you can see 1 times 2 minus 2 times 3 and 1 times 1, and then the values you get, you add them together, which is what was done here. And for this second part, you take the same first row and multiply the second column and get the second part. You take the second row, multiply the first column, take the second row again and multiply the second column. So if it was 3, then you also do for the third one. You take the third row, multiply, and you keep going like that until you're able to finish the number of rows and the number of columns you have in that question. Now let us consider what we call the transpose of a matrix. When is a matrix? When is a particular matrix called the transpose of another matrix? Now, the transpose of matrix is formed when you swap the rows and columns. The moment you make the rows the columns and the columns the rows, you form the transpose of a matrix, and it's usually denoted by the superscript T. Sorry, not subscript, superscript. So if a matrix has a superscript T, then you know that we are not dealing with just the matrix, we are dealing with its transpose. For example, let's look at an example. You can see that here we have the matrix A, matrix A, which is this, and it has 3 rows, 1, 2, 3. The 1, 2, 3, 4 is a row, 5, 6, 7, 8 another row, 9, 10, 11, 12 is the last row. And then you want to form a transpose. All we need to do is to take this first row, 1, 2, 3, 4, make it the first column, 1, 2, 3, 4. Take the second row, 5, 6, 7, 8, make it the second column, 5, 6, 7, 8, and take the third row and make it the third column. That way we have been able to form the transpose of that. And that drives us to a very interesting part of matrix, the special matrices. What are the special matrices? The special matrices are matrices that have special names due to special characteristics that they show. For instance, the first one we have here is the square matrix, and the square matrix is a matrix that has the same number of rows and the same number of columns, meaning that if the size of the matrix is m by n, whenever the m and the m are equal, we have a square matrix. Like for instance, we have A here, which is a 2 by 2 matrix. We have B here, which is a 3 by 3 matrix. So if we have that, you can see that they are both square matrix. Then the next type of matrix we have is the diagonal matrix. Now, diagonal matrix is the matrix where all the elements are 0 except the leading diagonal. As you can see, all the elements are 0 except this leading diagonal. So this is a diagonal matrix. And the last type of special matrix we're going to be talking about today is the unity or identity matrix. Now, the unity matrix is also called the identity matrix or identity element. It is basically a diagonal matrix. The only difference is instead of having all just numbers in diagonal, all the numbers in diagonal must be 1. As you can see here, they are all zeros, but the diagonals must be 1. Our matrices for today. Thank you for watching this video up to this point. If you have watched this video up to this point, please do well to send in your questions. If you have any, you can just quickly drop them as a comment in under this video, and I assure you that any questions you have, I will do well to answer them, as many as they come. Thank you for watching this video. Please do well to like the video, comment, subscribe to our channel. If there's any way you feel we can improve and we can become better, please subscribe to our channel. Help us become better. Please like, please subscribe, comment on how you feel we can become better, and I'll show you all these comments will be taken into consideration. Thank you. Usually we have a single number.